When most people think about hydrogen, they picture towering storage tanks, gleaming electrolyzers, pipelines, or fuel cells powering vehicles. But none of those machines can operate alone. Hidden beneath every pipe and inside every control cabinet is an invisible world of information. Thousands of sensors are continuously measuring pressure, temperature, voltage, flow rates, gas purity, and equipment health. Every second, these measurements become digital signals flowing throughout the facility. While hydrogen molecules move through pipes, data moves even faster through fiber optics and industrial networks. In many ways, modern hydrogen production is just as much about information as it is about energy. A hydrogen plant is far more than a collection of individual machines. Electrolyzers communicate with power converters. Compressors exchange information with storage systems. Cooling equipment reports temperatures, while purification units monitor hydrogen quality. Every component constantly sends and receives information. This continuous communication allows the entire plant to operate as one synchronized system, rather than hundreds of isolated machines. Without this invisible conversation, production would quickly become unstable. Hydrogen is one of the lightest elements in the universe, yet producing it safely requires extraordinary precision. Small changes in temperature can affect efficiency. Tiny pressure variations may indicate leaks. Electrical current must remain carefully balanced to protect electrolyzer stacks. Water quality influences hydrogen purity. Every measurement contributes to keeping the plant efficient, reliable, and safe. What appears to be a simple industrial process is actually controlled by millions of tiny engineering decisions happening every minute. Collecting data alone solves nothing. The real value comes from interpreting what those numbers mean. Modern industrial software continuously analyzes enormous streams of information, searching for patterns humans would never notice. Artificial intelligence identifies equipment operating outside normal behavior, predicts declining efficiency, and recommends adjustments before problems occur. Instead of reacting to failures, operators can prevent them altogether. Every hydrogen facility has a central control system acting as its digital brain. Information arrives from thousands of sensors spread across the plant. Advanced control software compares current conditions against optimal operating parameters and automatically adjusts valves, pumps, compressors, and electrical systems. Hundreds of automated decisions happen every second without human intervention. This invisible intelligence keeps hydrogen production stable, even while external conditions constantly change. Control rooms today look dramatically different from industrial plants of the past. Engineers are no longer turning manual valves or watching analog gauges. Instead, they supervise intelligent automation systems displayed across large digital dashboards. Their responsibility has shifted from operating machinery to overseeing complex software capable of managing entire facilities. Human expertise remains essential, but now it works alongside artificial intelligence rather than replacing it. Imagine having a perfect virtual copy of an entire hydrogen plant. Engineers call this a digital twin. Every pump, valve, compressor, and electrolyzer exists simultaneously in both the physical world and inside powerful simulation software. As equipment operates, the digital twin mirrors its behavior in real time. Engineers can predict future maintenance, simulate operating changes, and test new ideas without interrupting production. It allows industries to solve tomorrow's problems before they happen. The journey does not end once hydrogen leaves production. Pipelines become intelligent infrastructure filled with pressure sensors, flow meters, leak detection systems, and automated valves. Operators can monitor hundreds of kilometers of pipelines from centralized control rooms. If abnormal conditions appear anywhere along the network, the system immediately alerts engineers and can automatically isolate affected sections. Invisible monitoring creates visible reliability. Even hydrogen trailers have become mobile digital platforms. GPS continuously reports vehicle location. Pressure sensors monitor storage cylinders. Temperature sensors protect fuel quality during transportation. Fleet management software optimizes delivery routes based on customer demand and production schedules. Every shipment generates valuable operational data that improves future logistics. Hydrogen is no longer simply transported. It is intelligently managed throughout its journey. Hydrogen fueling stations appear simple from the outside, but internally they perform hundreds of automated safety checks every time a vehicle arrives. Compressors verify pressure levels. Storage vessels monitor fuel availability. Dispensers confirm hydrogen purity while communication systems coordinate fueling protocols with the vehicle itself. Every refueling event creates another layer of operational intelligence that improves future station performance. Across entire regions, multiple hydrogen facilities can now be monitored from a single command center. Engineers watch live data arriving from production plants, storage terminals, pipelines, fueling stations, and transportation fleets. Instead of managing one facility, they supervise entire hydrogen ecosystems. Problems are identified, analyzed, and resolved before customers ever notice disruptions. Artificial intelligence is rapidly becoming one of the newest members of every hydrogen operation. AI forecasts electricity prices, predicts renewable energy generation, estimates hydrogen demand, schedules maintenance, and detects equipment degradation weeks before traditional inspections. Rather than replacing engineers, AI gives them better information, allowing faster and more informed decisions. Individual hydrogen plants are increasingly connected through secure industrial cloud platforms. Data flows between manufacturers, utilities, maintenance companies, transportation operators, and customers. Lessons learned at one facility can improve performance at another thousands of miles away. Instead of isolated plants, the hydrogen industry is becoming one continuously learning global network. Pipelines move hydrogen. Transmission lines move electricity. Fiber optic cables move information. Together, they form the three hidden infrastructures supporting the clean energy economy. Remove any one of them, and the entire system becomes less reliable. Data is no longer simply supporting hydrogen, it has become essential infrastructure itself. Large industrial parks increasingly operate as integrated energy systems. Renewable electricity powers electrolyzers while waste heat is recovered, hydrogen is stored, batteries balance electricity demand, and industrial facilities consume clean fuel. Digital coordination allows every component to support the others, maximizing efficiency while minimizing waste. Future cities will rely on hydrogen in ways that extend far beyond transportation. Public transit, backup power, ports, airports, manufacturing, hospitals, and data centers may all become connected through intelligent hydrogen infrastructure. Digital management systems will continuously balance energy demand, ensuring reliable operation across entire urban regions. As renewable energy expands, hydrogen networks must respond dynamically to changing weather conditions and electricity production. Artificial intelligence automatically decides when to produce hydrogen, when to store it, and when to deliver it to customers. Entire energy systems begin operating with minimal human intervention while remaining continuously supervised. Individual hydrogen plants eventually become regional networks. Regional networks become national infrastructure. Pipelines, production facilities, storage caverns, ports, renewable energy farms, and industrial customers become digitally connected across entire countries. National hydrogen systems depend on real-time information, flowing just as reliably as hydrogen itself. Energy rarely respects political borders. Continental hydrogen corridors are emerging to connect renewable resources with major industrial regions. Cross-border pipelines, shipping terminals, and coordinated electricity markets require unprecedented levels of digital communication. Information becomes the glue holding international hydrogen infrastructure together. As hydrogen markets expand worldwide, operators must coordinate production across thousands of facilities. Weather forecasts, electricity markets, shipping schedules, industrial demand, and storage availability all influence where hydrogen should be produced and delivered. Global optimization becomes impossible without advanced digital intelligence operating continuously. Satellites now monitor renewable energy resources, weather systems, industrial activity, and infrastructure performance across the globe. Combined with artificial intelligence, this information helps predict where hydrogen will be needed, where renewable electricity will be available, and how global supply chains should respond. The hydrogen economy is evolving into something much larger than individual projects. It is becoming planetary infrastructure connecting renewable electricity, transportation, manufacturing, aviation, shipping, agriculture, and heavy industry. Every new connection increases both the complexity and the value of the overall system. Researchers are now creating digital models capable of representing entire energy systems. These digital twins combine weather forecasting, renewable generation, hydrogen production, electricity transmission, transportation, and industrial demand into one evolving simulation. Decisions that once relied on experience increasingly rely on predictive intelligence. The future is not simply hydrogen, nor is it only batteries, artificial intelligence, or renewable energy. The future belongs to systems where every technology supports every other technology. Electricity produces hydrogen. Hydrogen stores renewable energy. Artificial intelligence coordinates operations. Digital infrastructure connects everything together into one intelligent ecosystem. The next time you see a hydrogen plant, remember that most of its intelligence is invisible. Beneath every valve is a sensor. Behind every compressor is software. Above every pipeline is a communication network. Across every facility flows an endless stream of information that keeps the entire system operating safely and efficiently. Hydrogen may carry clean energy, but data carries the intelligence that makes the hydrogen economy possible. Once you understand these hidden systems, you begin to see that the future of energy is not only built with molecules, it is built with information.